Okay, here we go. What's a function? Y and X. Okay. I like that. What else? Describe to me a function. A way of solving something. Input, output. Okay, I like that. Something else you think of. Couple vertical line tests. Does that ring a bell? I don't think so. How about domain and range? All right, so we got Zach in here. Who's another soccer player in here? Okay, all right, so we're gonna go with Zach and Braden. All right, so Zach and Braden, you guys are two soccer players, okay? All right. Now, is it possible that you guys play a soccer game and the next day we look in the box score and see that each of you scored exactly 3 goals? Is that possible? Probably won't happen. That's not the point. Point is, it possible? Is it possible you could look in the box score and see that both of you scored 0 goals in the game? Is it possible you could see Braden scored 1 and Zach scored 20? Is it possible we could see that Braden scored 19 and Zach scored 2? Those are possible, right? Is this possible? Is it possible that we look in the box score and we see that Zach scored both 0 goals in the game and 5 goals in the game? No, that's not possible, is it? The fact is that this is an excellent illustration of what a function is. See, Zach and Braden are the players. They are the inputs. They output goals. Can they output the same number of goals? But can they output a different set of goals? No, they can't. You can't output 2 different sets of goals, can you? I mean, I would just be trying to understand. It just wouldn't make sense. Came home. How'd the game go, Zach? Oh, the game went fine. I scored 2 and 5 goals, both in the same game. How did that happen? I don't know. You'd have to come up with some interesting way of describing the story, okay? You might say, well, at one time I had 2 and another time I had 5. Well, still, that would mean you scored 5 total goals, okay? So that's interesting. So here's the definition of a function, loosely. Every input goes to exactly 1 output, right? Here's what you need to memorize for the test. A function is a relation in which every element of the domain corresponds to exactly 1 element of the range. Now, you can do that. Some people say, I had one person option one time, like, this is an English class, you shouldn't have to memorize anything. Like, that's fine. There's a lot of other classes you can take. You take my other math class instead, not get college credit if you don't want to do it. It's fine. Options we choose, right? You have to memorize that. Verbatim. If it's wrong, it's wrong. There's no passing, going, collecting $200. So let's do an easy problem. Given the following functions, evaluate these pieces. F of x is equal to 3x minus 5. This notation means f of negative 3 means we take negative 3, we plug it into the function machine, we get an output. So you take 3 times that negative 3. Wherever you see an x, you replace it with that negative 3. So that's the notation that we use in mathematics, and we can be confident that because it is a function, when we plug something in for x, we get out exactly one value. We know that we're not going to come out with more than 1. 3 times negative 3 is negative 9, minus 5 is negative 14. Okay? So f of 0 would be 3 times 0 minus 5, or negative 5. F of 2 would be 3 times 2 minus 5, or 1. How about f of a? What would I do there? Three a minus 5. If you did f of a minus b, you get 3 times a minus b minus 5, or 3a minus 3b minus 5. You try b on your own and make sure that your final result, your expression, doesn't have parentheses around it, okay? Don't use any grouping symbols with your final answer. Try b on your own. Okay, you should come up with 15, 0, 0, a squared minus 2a. And the last one, if you FOIL out the a minus b, you should get a squared minus 2ab plus b squared. And make sure you distribute the negative 2 all the way through, so a minus 2a and a plus 2b. Any questions on those? This is a review piece, right? Seen this type of idea before. So please just note that this is a perfect example where, say, Zach is number 0 and Braden is number 2, and they both score 0 points in the game. Okay? So that is allowed to be a function. You can have the same output, but you can't have an input going to 2 different outputs. So now we look at something that looks confusing that is really quite straightforward and simple. Right now we are simply going to identify the function values for these piecewise functions. Piecewise functions are really important as we move further and investigate calculus eventually. Don't draw this, but a piecewise function, I'm not drawing in this example right here, but it would look something like this. You would have, this would be the graph for part of the time, and then, say this would be the graph for the other part of the time. So you can break a function up into 2 different pieces depending on what type of domain you have. Don't worry about that. You're going to learn how to graph it. I think that will probably be one of the more challenging parts of your next test for you, is to be able to graph piecewise functions. But we'll spend a lot of time on it, and hopefully you'll get pretty good at it. I'm not going to identify all of the function values, but I am going to do f of negative 3, f of 0, and f of 2. Now, a piecewise function tells me what to do. It says I'm going to be the top function if the x value is less than 0. But if the x value isn't less than 0, if it's greater than or equal to 0, then I'm going to be the bottom function. So if we want to identify f of negative 3, do I type in negative 3 the top one or the bottom one? The top one. Why? Because negative 3 is less than 0. It satisfies that criteria, so therefore I have 2 times negative 3 minus 1 is negative 7. Do I type in 0 to the top one or the bottom one? Bottom one, because it is equal to 0, and I get 0. Then obviously 2 is greater than or equal to 0, so I use the bottom one. And I get a negative 2 minus 3 is negative 5. So looked really confusing due to all the algebra written down, right? The fact is, it's really a pretty straightforward idea. I'd like you to evaluate at this time f of negative 3, f of 0, and f of 2 for this next example. Go. Did you get 4, 18, and 16? A constant can be a function. That's a horizontal line that travels through 18. Okay. Everybody good with that? Okay, so we've done 3 pieces, function values of piecewise functions. Now we got this last piece. We're just going to do 3 of these problems. You have time to work. So we want to be able to find that rule. And that's going to require us to find f of a. F of a is not very difficult. F of a plus h, that might be a little bit more challenging. But then we're going to take the 2, we're going to subtract, and we're going to divide by h. And it's pretty cool what happens. There's a lot of calculus that goes behind using this eventually. This is something that is in your pre-calculus textbook so that you can be efficient next year when you actually do it in calculus. So we're going to practice this example here. I'm going to lay it out very simply by writing f of a plus h is equal to, I take the a plus h and I plug it in for x, and I get a plus h quantity squared. Everybody agree that's f of a plus h? Okay, now I'm going to write down f of a. F of a is just a squared. You okay with that? So now I'll put it into the rule. I'm going to take f of a plus h, which is right there. So a plus h, quantity squared. And it says minus f of a. So minus a squared all over h. If you don't see where I got the expression in red, let me know, because I used to just write that down, but now I write down the green part, and people seem to understand how I came up with that better. Now I simplify. What's a plus h quantity squared? All over. Now, here's what's going to happen every time. If it doesn't have an h, it should cancel. If it doesn't have an h, it should cancel. What cancels? The a squareds cancel. Furthermore, everything that's left should have an h, and you should be able to divide it off. So I can factor an h out of the top, leaving me with 2a plus h all over h, and now those h's will cancel, leaving me with the expression 2a plus h. So that rule for the function x squared simplifies to 2a plus h. Okay, let's try another example. G of a plus h is 2 times a plus h minus 3. And g of a will be just 2a minus 3. So I'm going to take the first part minus the second part, all divided by h. 2 times a plus h minus 3 minus, I'm going to put parentheses down in front of the second one. Why would I do that? So that way I distribute the negative. all over h. Okay, when I get rid of the parentheses, what does it look like? Somebody take me through. If it doesn't have an h, it should cancel. What cancels? The 3's, the 2 a's. We're left with, can we divide the h off? Yep. If some of you are wondering what's the application here, notice how 2 is the slope. Here you came up with 2a plus h. That, in a strange way, represents the slope of that function at any given point. In calculus, you're able to find the slope at 1 point instead of 2. And we use this. Let's do one more example. H of a plus h. 5 times a plus h minus a plus h quantity squared. H of a, 5a minus a squared. So I'm going to subtract the first one minus the second one all over what? All over h. So 5 times a plus h minus a plus h quantity squared minus, I'm going to use parentheses, 5a minus a squared all over h. Looks like a lot, huh? In fact, you might even be led to believe that stuff won't cancel, but if you do your work properly, you'll see that it works out well. So, what do I got? Good. No equal sign, just a minus. Good. We'll distribute the negative sign through and get a minus 2h. Good. Good. Distributing that negative sign. Good. All over h. Guys, people actually like this stuff because they like to cancel stuff off. Makes you feel good. Some of you guys make checklists for yourself during the day just so you can cross it off. In fact, some of you make checklists, and on that list you put stuff that you've already accomplished just so you can cross it off. So we'll get rid of this stuff. We'll have our fun. We'll cross stuff off. Good times. Does everything that's left have an h? Factor the h out, and you get 5 minus 2a minus h all over h. Cancel, leaving 5 minus 2a minus h. Not too bad, huh? Now, it's definitely more difficult when we get to rational functions as well as radicals, but that's a whole different time, okay? So we're going to take a break here, press pause, and here's what you can do. A, you can use this time right now to work on whatever you want, but the assignment from what we did today is right here. Now, the fact is 11 through 16, 21 through 24, let's say that you didn't start that right now. Let's say you didn't get to it till this weekend. That's going to be easier stuff, and you're probably not going to have that big of a problem trying to do it. This is a little bit harder because these are the problems just like what we did that people seem to struggle with a little bit more. Now, the good thing is that we're going to start with that content again on Monday after your test. So if you don't know how to do this, we'll start with a checkpoint that Monday to refresh your memory, and then we'll go into more examples, and you'll actually have a worksheet in class to practice some of those problems and get real confident with it. we will make sure that we ensure you're learning for that piece. No, no. I had to insert this because we can't afford another day. We can't get any further behind. So, yeah, go ahead. Go for me while you're at it.